Hi students, today we can discuss the chapter 4 carbon and its compounds. So in this topic or in this chapter we'll be talking about the nature of carbon, its bonding type and all. Okay. See, most of the things are around. If we see around, see like this, the things which are shown in the picture are the things which we see around. So all the things, almost all the things which we see around are made up of compounds of carbon. All living structures and non-living structures such as food, clothes, medicines, books, etc. are carbon based. So when a carbon compound is burnt, carbon dioxide and water are produced. Okay, so in the Earth's crust, if you observe, we can see that side has only very few. That means 0.02 percentage of carbon only. And that too in the form of minerals like carbonates, hydrogen carbonates, petroleum, coal, etc. And in the atmosphere, the calculation says it is 0.03 percentage of carbon dioxide. But carbon has got immense importance because all the things which we see around are made up of carbon. So there is something special about carbon. So it is very important to study about carbon. That is what we are going to do in this chapter. First, we are going to talk about bonding in carbon. Okay, so we know carbon has the atomic number 6. Its electronic configuration is 2 and 4. 2 in the K shell, 4 in the L shell. So outermost shell is having 4 electrons. Okay. So for the carbon to form bond, either it can give out these 4 electrons or it can gain 4 extra electrons from other atoms. Okay. That is what we learned, either gaining or losing of electrons. So what if it gains 4 electrons? Gaining of 4 electrons and forming C4 minus anion. Okay, makes it difficult to hold 6 protons and 10 electrons. 6 protons, it is holding 10 electrons is going to be very, whereas 6 protons we can find in the center of the nucleus of the atom. Okay, 6 protons it is having 6 protons. That means it is 6 what positive charge is there in the 6 positive charge is there in the nucleus of the carbon. Okay, this is the condition. And if it gains for more, it becomes one here, one more here you can draw, one more here you can draw, and the other you can draw here. This is the condition. So 6 protons to hold on 10 electrons is going to be very difficult. Okay, and losing 4 electrons. Losing 4 electrons needs high energy to live. See, if it want to lose these 4 electrons, okay, that is shown in the outer shell. The 4 electrons which are shown in the outer shell has to be removed. Okay, that is losing of, which is going to be very difficult because 6 protons are there holding strongly the 6 electrons, and to remove that 4 electrons we need a high energy. So both uh, possibilities are difficult for carbon. Okay, so carbon is gaining its or solving this problem by sharing its valence electrons, by sharing its valence electrons, okay, with the other atoms of carbon or with other atoms elements, atoms of other elements. Okay, the simplest and so we will learn something about sharing of electrons, how elements share electrons to form molecule. Okay, we'll discuss that, then we'll be coming back to carbon. Okay, so the simplest molecule formed by the sharing of valence electrons is that of hydrogen, because hydrogen is having only atomic number 1. This is the case with hydrogen, only 1 electron, and the other hydrogen atom with 1 electron. So what they are doing is to form hydrogen molecule is sharing the 2 electrons or sharing 1 electron each. Becomes 2 electrons here. See, now look at the hydrogen atom, single hydrogen atom, it is having 2 electrons. That means that shell is completely filled. Okay, and this also reaching the completely filled state. So there, by sharing the one pair of electrons, 2 hydrogen atoms are gaining a stable state, and we can be represented like this. the bond formed by sharing of electrons. Okay, it is called a covalent bond. Covalent bond. Covalent bond. Okay, which can be represented by a single dash line. A dash will. H dash H means H forms a single covalent bond with H. Okay, forming hydrogen molecule. Okay, and see, this is also possible. Carbon can is having 4 electrons in the outer shell. It can share electrons with the other atoms also, other hydrogen atoms also, like this. Okay, so that is how a covalent bond is formed by sharing of electrons. Okay, now we'll study about sharing of electrons in the case of mm, chlorine molecule. Okay, so chlorine molecule is having atomic number 17, electronic configuration 2, 8, 7. So last shell is having 7 electrons. So it need one more electron to become a stable state. Okay, or to just like argon. Okay, so what it is doing is it will be sharing one electron so that it reaches 8 electron 2, 8, 8. That states that stable state by sharing. See, this is what is happening. One chlorine and the other chlorine is sharing its 1 electron each. Okay, contributing 1 electron each, forming a single covalent bond. Cl forms a single covalent bond with the Cl, forming chlorine molecule. Okay, and see, so it is single covalent bond, single line only. But now coming to the case of oxygen, see, it is having last shell 6 electrons in the last shell. So it will need 2 more electrons. Okay. So what it will do, it will share 2 electrons. So this, both the oxygen will contribute 2 electrons for the bond formation, and there forms 2 pairs of electron sharing. Okay. That means 2 bond or double bond it is called. So oxygen forms a double bond with the other oxygen, forming the oxygen molecule. Okay, why double bond? Because sharing of 2 pair of electrons. Okay, now coming to this is showing in the water molecule, oxygen and 2 hydrogen. We know the formula of water is H2O. See, this is the way. So one pair of one electron, the oxygen atom, 1 electron will be sharing with 1 hydrogen atom. The other electron will be sharing with the other hydrogen atom. See, now see the condition. Oxygen is with 8 electrons in the last shell, hydrogen with the 2 electrons in the last shell. Okay, everybody is happy with the stable state. Okay, H forms a single covalent bond with O, then forms another covalent bond with H, HOH. This is the bond formation in water molecule. Now see the electron dot structure of nitrogen atom. Nitrogen having 5 electrons in the last shell. That means it need 3 more. So it has to share 3 pair of electrons, or each one will be contributing 3 electrons for the bond formation. And so 3 pair of electrons are being shared and the bond formed will be triple bond. Okay, so nitrogen molecule is formed by sharing 3 pair of electrons, or we'll say nitrogen forms a triple bond with another nitrogen to form the nitrogen molecule. And see the case here that 3 electrons will be shared with the 3 different hydrogen atoms. Okay, and it forms another molecule called ammonia, NH3. Okay, so that is covalent bond formation. Now there is a bond molecule given. It is methane, the molecule. The formula is CH4 and 1 carbon, 4 hydrogen. Okay, so carbon is sharing the 4 electrons with the 4 different hydrogen atoms. Now all the hydrogen atoms and the carbon atoms is the stable state after sharing. Okay. Okay, that is how what covalent bonding is taking place. Okay. Now, so the bond formed by sharing of electrons is called a covalent bond. And see, here we'll be talking about the properties of covalently bonded molecules. Okay, covalently bonded molecules have strong bonds within the molecule. Okay, within the molecule they have. That means CH bond is strong, but CH4 and other CH4 atom attraction, or the bond between, or the attraction, intermolecular force of attraction will be very weak. So what happens? This gives rise to the low melting and boiling points of these covalent compounds. Okay, and since there are no electrons or no ions are formed, they are poor conductors of electricity. So the answer for the question why they are poor conductors of electricity or why they are having low melting and boiling points are here. Okay, that's it. Then one special property of carbon it is showing it is for allotrope formation. That means carbon by arranging its atoms in a different way it forms a different form. Okay, for example, this is structure. See the arrangement. You can see that is four. One carbon is joining with the other four carbon atoms and forms a special structure. That is the structure of diamond. And see in this case, graphite. It forms a hexagonal structure and two hexagonal layer will be joining by another strong force of attraction. Okay, that hexagonal array forms a bond with each other, and we are getting the structure of graphite. And the third structure is of Buckminster-Fullerene. It is 60 carbon atom, nearly 60 carbon atoms are forming a ball, football-like structure. Okay, this is called a Fullerene structure of full Buck. The first identified one was carbon 60, which has carbon atoms arranged as a football. This looked like the geodesic dome designed by the US architect Buckminster Fuller. So the name Buckminster Fullerene. Okay, so these are the three different types of allotropes of carbon: diamond, graphite, and Buckminster Fullerene. Okay, and diamond is the hardest substance. Graphite is the thing is what is special about this allotrope, they all are having different properties, different nature. Okay, the hardest substance is diamond. Graphite is smooth, but it is a even though it is a non-metal, it conduct electricity. Okay, slippery and very good conductor of electricity. Then synthetic diamonds can be produced by subjecting pure carbon to very high pressure and temperature. So we can make a diamond in the laboratory. Yeah, these are small but indistinguishable from natural diamonds. Okay, so we can make very much like a natural diamonds, very much like a natural diamonds. Okay, now the reason for the or what is the reason for the versatile nature of carbon? So carbon is having a versatile nature means, okay, what is the reason for that? The reason we can give answer in two words. The reason is number one catenation and number two is tetravalency. Okay, so catenation and tetravalency. We'll discuss one by one. Catenation and tetravalency. Number one, first property is catenation. What is that? It is the ability of carbon atom to form bonds with other atoms of carbon, giving rise to large molecules like this. Okay, one after another it is joining to form long chains, and even branched chain is possible, even ring chain is also possible. Okay, so this makes or this helps carbon to increase its number of compounds. Okay, and no other element is having such a property. Due to the special size and the special size of the carbon, this ability is possible for carbon. Okay, then other element is silicon, which can form compounds with hydrogen which have up to 7 to 8 atoms. Sulfur also forms some 8 sulfur joined to form a chain. A ring-like chain is there, but no other atoms are capable of catenation like carbon, like long chain, branch chain, closed chain, lab. All these are not possible for other elements. That is the peculiar nature of carbon atom due to its small size. Okay. Now the second reason for the versatile nature of carbon is tetravalence. The word itself gives a meaning. Tetra, 4, valence is 4. We know the valence of carbon is 4. What is so special about that? So since it has got 4 free electrons in the outer shell, it can combine with the 4 other elements easily with other elements like oxygen, hydrogen, nitrogen, sulfur, chlorine, etc. What is the advantage? It gives uh, giving specific properties. Okay. And what is the advantage? It gives a large number of compounds. Okay. Carbon atom. See the answer for why. Okay. Carbon atom is small size. So the nucleus can hold the shared pairs of electrons strongly. So carbon can make very stable compounds with the other element. So that is what is special about carbon. It is small, so it can hold the electrons so strongly, so it forms a stable compounds. Okay. And so as the size of the element increases, okay, because it's becoming bigger and bigger, the bond becoming weaker and weaker. Okay, keep in mind. Now, uh, previously, it was thought that organic or carbon compounds could only be formed within the help of a vital force that in living system is needed. Only that nobody else can prepare. But that we believe was disproved by preparing urea from ammonium cyanide. Who is that? Wohler. Frederick Wohler disapproved by preparing from ammonium cyanide. He prepared a urea, which is an organic compound which is found in the animal bodies. Okay, so carbon compounds except for carbonates, oxides of carbon, carbonate and hydrogen carbonate salts are studied under organic chemistry. Okay, so carbon compounds we are dealing under the topic or under the heading organic chemistry except for carbides, oxides and carbonates and hydrogen carbonates. Okay, so Wohler prepared urea, an organic compound. Next is the saturated. What do you mean by saturated and unsaturated carbon compounds? Okay, saturated means, see, if you observe the saturated compound between carbon, there will be only single bond. If there is this is also single bond in this case, this carbon single bond only, between these two carbon only single bond. Okay, it can represent like this. So if you observe the structure, it will be having only single bond between carbon. Okay, between carbon is very important, others we are not bothered about. So if between carbon if there is only single bond, we call it a saturated compound. Otherwise we call it, if there is a double or a triple bond like this, we call it an unsaturated compound. Okay, so examples are ethane. For this one, it is ethane, propane. These are all examples of saturated compounds. Whereas ethene, C2H4 is the formula. Ethane, C2H2 is the formula. Okay, these are having double and triple bond respectively between carbon. So they are called unsaturated compounds. Okay, now what is special about carbon? We already talked. It is having a capacity to form chains. So carbon forms a first compound with the hydrogen, second compound with the hydrogen. That means two carbon atoms are there, three carbon atoms are there, 4, 5, 6, like that. All with the single bonds only, no double bond anywhere between carbon. Okay, they are called a alkane family. And if it is one carbon, it is methane, two carbon ethane. Prop stands for three carbon. Ane is ending in ane means it is a single bond only. Okay, so butane, pentane, hexane. So meth, eth, prop, but, pent, hex. These are the indicating the number of carbons present. Okay, meth for 1, eth for 2, prop for 3, like that. But for 4, pent, hex, etc. are by 4, 5 and 6 carbons respectively. Okay, that's it. Now we already talked about this branching it is. Okay, but see here it is showing a carbon compound with 4 carbon atoms. This is one form, this is branched form. What is special about that? Number of carbon atoms are equal. And if you substitute hydrogen, Okay, if you fill hydrogen in both the cases, we can see that, and if we add up, we can see that the formula, molecular formula of the compound is C4H10. But see, the structural formula is different, isn't it? This is long chain, this is branched. These kind of structures are called structural isomers, differ in their structure only, but molecular formula remain the same. Okay, C4H10, that is butane, which is having two isomers, structural isomers. What are structural isomers? Compounds. Here it is written. Compounds with identical molecular formula but different structures are called as structural isomers. Okay, that is it about structural isomers. Now, that carbon can form ring also. That also we learned. See, one example for a ring compound is given here, cyclohexane. The formula is C6H12. This is having 6 carbon in a cyclic structure with the completely filled with the hydrogen. 6 carbon with single bonds only. Okay, but it's a ring form. Then another compound, cyclohexane, it is called, formula is C6H12, and the structure is given here. Electron dot structure, and this is bond line structure. This is skeleton structure, skeletons, carbon skeleton. This is complete molecule structure. This is electron dot structure. Okay, you can very easily draw this. Isn't it? Now, chains. Okay, no ring. One second, ring. It is showing. It's another compound with the ring structure. It is, the name of the compound is benzene. Formula is C6H6, 6 carbon joined by alternate double bonds and single bonds. Okay, compound is called benzene. Okay, compound is called benzenes. And here it is talking about saturated hydrocarbons. We already discussed, they are called alkanes. And if there is a double bond, they are called alkenes. If there is a triple bond, we call it, if there are, okay, between carbon triple bonds are there, we call them alkynes. Okay, so these are all the increase this capacity of a carbon to form structures like this uh, makes it capable of forming n number of compounds. Okay, n number of compounds. So what happens, and it also forms compound with the heteroatoms. Heteroatoms mean other than hydrogen. So if you